Welcome back to the next edition of Mr. Wicklam's Virtual Math Classroom. Today what we're going to be talking about is arrays and factors. Now, when we take a look at the introduction here, we're taking a look at 3 times 5. When we break it down, what is 3 times 5 really? 3 times 5 is basically just taking 5 and adding it 3 times. So you have 3 5s. So let's do that. 5 plus 5 plus 5. And that's basically what 3 times 5 is. You could do 3 5s, or you can do 5 3s. You can do it the other way around. So you can go 3 plus 3 plus 3 plus 3 plus 3. Now, could you imagine having a longer number and having to write the addition statement out that long? It would take a long time, especially when you get into thousands and millions. So you do 1,000 times 1,000. Imagine writing 1,000 out 1,000 times. That's why we use multiplication, because multiplication is the short form for addition. It's the short form for addition. Okay, so what we're going to look at is we're just going to take a look at 3 times 2 just to make sure that we're all on the same page. So looking at 3 times 2, you guys probably know that the answer is 6, but how do we do that as an addition statement? Well, we have, if we always look at it, we have 3 2's. So always start with the first number, you have 3 of the second number. So you have 3 2's, 2 plus 2 plus 2. We can all skip count by 2's, 2, 4, 6. Okay? 4 times 3, so you have 4 3's. Okay? So let's do that. 3 plus 3 plus 3 plus 3. And really, guys, that's all multiplication is. It's just the short form for addition. Now, we're going to be looking at our book. And today we're going to be looking at something called arrays. And what an array is it's just rows of dots. Okay, so arrays, don't get reading anything into it. Array is basically just rows of dots. So you can kind of see this right here would be called an array, because it's just rows of dots. So that's all an array is. It's just rows of dots. So when we take a look at this array, what do we have? So we have how many rows? And remember, when we look at rows, we always start here and we go down. Okay, so this is a row, this is a row, and this is a row. So how many rows do we have? Well, we have 1, 2, 3 rows. Now, how many dots are in each row? Well, let's count. We have 1, 2, 3, 4, 5. So we have 5 dots in each row. So on the bottom line, what we want to do is we want to be able to write a multiplication statement. So it's pretty easy. You take the amount of rows you have 3 rows, you have 5 in each row. And how many do you have all together? We can skip count by 5s, 5, 10, 15. You can count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You can do it either way. So you have 15. So it's pretty simple, guys. All we're doing is we're just warming up to multiplication all over again, because sometimes we lose focus on multiplication and we just need to keep warming up. So let's take a look at our next one. So here's our array right here. How many rows do we have in our array? Well, last one we had 3. Well, how many do we have? 1, 2. We have 2 rows. How many dots are in each row? 1, 2, 3, 4. So we have 4 dots in each row. So our multiplication statement is going to be the amount of rows multiplied by the dots in each row, and we get our total, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, what we're going to see is we're going to see where they want you to write the product. What is the product? Well, pretty simply, this right here is the product, the multiplication statement. This is the product. If we're looking in math operations, if you're looking for the sum, that's addition. If you're looking for the difference, that's subtraction. When you're looking for the product, that is multiplication. Okay, so this right here is the product. So what it wants you to do is it wants you to write the product or the multiplication statement. Okay, so let's take a look at our first example. Here's the array, and I'm just going to add to it. Okay, now how many rows do we have? That's the first thing we want to look for. Just because if we look at this, rows, dots in each row, that's how we wrote the product. Well, we have 1, 2, 3, 4, 5 rows. So all I'm going to do is I'm just going to draw arrows just to continue to guide us. So that's the amount of rows. How many are in each row? We have 1, 2, 3. And I'm just writing down dots in each row. Okay, and so what that does is it just helps us to know the product. So you can kind of see that this is the inverse, right? I had 3 rows before, now I have 5. And I have 5 rows of 3, whereas I had 3 rows of 5. Okay, but that is the product. Let's take a look at our next example. How many rows do we have? You should be able to figure this out in your head by now. And we're going to multiply it by the amount of dots in each row because we want to get the product. So how many rows did you figure out that we had? Well, we have 1, 2, we have 3 rows. How many dots are in each row? If you count them, 1, 2, 3, 4, 5, 6, and 7. That is our product. 3 times 7. Okay? So you're going to be seeing that, and you're going to be seeing some problems. You're going to be seeing just draw the array now, because that's what we're moving on to. So how would you draw this array? So you know that this is the product. You know from what we have done, the first number is always the amount of rows. So if we have 6 times 2, and we know that the first number is always the amount of rows, how many rows are we going to have? Well, this tells us how many rows right here. So we know we have 6 rows of 2 dots in each row. So let's draw that. 1, 2. And that's what the array would look like. So what we have is we have 1, 2, 3, 4, 5, 6 rows. How many dots are in each row? 2. And you can see that I have 2 dots in each row. What you're going to also see is you're going to also see some word problems. And the word problems are going to look similar to what I have here. And basically what they're going to want you to do is they're going to want you to draw an array and possibly write what the multiplication statement will be. So it says in Bob's garden he has 4 rows of corn. There are 6 stalks in each row. How many stalks of corn does Bob have altogether? So what we did is we've been given the multiplication statement. So we need to look, and what we need to look for is how many rows Bob has. The next thing we need to look for are how many dots or stalks in each row. So how many rows of corn does Bob have? Well, Bob has, and let's circle it. Always circle, if you're unsure or underline, 4 rows. Okay, so he's got 4 rows. How many dots, or in this case stalks of corn, are in each row? In our case there are 6 stalks. So what's our array going to look like? It's going to have 4 rows. 1, 2, 3, 4. How many stalks? 6 are in each row. Sorry if my dots are a little small. I just don't want to be here all day and we're running out of time. So 4 rows, 6 stalks in each row. Now I want you to write a multiplication statement. Well, we've done that. We've wrote the multiplication statements or the product. So what we start is with how many rows? 4. How many are in each row? 6. And what does that equal? Well, 6 times 4, I know what the answer is because I have it in the top of my head, but you can count the amount of dots, and if you do that, you should come up with 6 times 4 equals 24. Okay? So, the next thing that we're going to move on to, because you are going to see this in your books today, we're going to be looking at factors. Now, all factors is you've completed lowest common multiples. All factors is how can we multiply to get 4? What numbers can we multiply to get 4? So let's do it by drawing arrays. Okay, so what can we multiply to get 4? Well, I know right off the bat I can multiply 1 and 4. So that's what I'm going to do. 1, 2, 3, 4. So that is 1 row times 4. How else can I get 4? Well, what if I flip these numbers around? I can do that. 2, 3, 4. So what I have is I have 4 rows of 1. Okay, makes sense. Is there any other way that I can multiply to get 4? I'm pretty sure that you can think of it. Skip counting might come to mind, especially by 2's. Oh, I can do 2 times 2. 1, 2, 1, 2. And that gives me 4. So the number 4 has 3 factors in it. It has 3 factors, or 3 multiples. And those are 1, 2, and 4. Now let's take a look at the factors of 6. Okay, so what can we multiply together to get 6? But right off the bat, there is always 1 and itself. When I say that, factors of 4, 1 and itself. So we can do the same for 6. 1, 2, 3, 4, 5, and 6. 1 times 6. 1 in itself. We can always flip that. Okay? So we know one factor is 1. What's another factor? Well, another factor is 6. Because I can go 6 times 1. I have 6 rows with 1 dot in each row. Okay, so we know 6 is another factor. How else can we get 6? What can we multiply together to get 6? Well, if we skip count and we, think of multiplying. So start at 1, which we did. Can we do 2? So let's take a look at 2. So 2, 4, 6. Oh, we can do 2. So we're going to do 2 rows. And how many are going to be in each row? Well, if I'm doing skip counting by 2's, so 2, 4, 6. So how many are in each row? 3. So what I have is I have 2 rows times 3. So if I can have 2 times 3, well then I can flip that around just like I did here, and I can have 3 rows of 2. And that's really the only multiples of 6 that I can get. So I can get 1, 2, 3, and 6. So it has 4 factors. Let's look at a number like 5. Okay, so right off the bat, we know that we can multiply 5 by 1 and itself. So let's do that. Let's do the same thing. 1 row, because I'm multiplying by itself, 1 by itself, which is 5. Okay, now let's do the other, which gives me 5 times 1. Is there any other way that I can do this? No, I can't get 5 any other way. So therefore, 5 is actually something called a prime number, because the only factors are 1 and itself which is 5. So the only factors for 5 are 1 and 5. So when you're looking at different numbers, let's say like 10, 11, 13, 16, look at what you can multiply them by. What can you go up by 2s? Can you go up by 3s? Can you go up by 4s? Can you go up by 5s, 6s, 7s, 8s? That's what you want to be able to figure out. And if you can, great. Draw the arrays and note what the factors are. If you can't, and you only get this, which is 1 in itself, that's fine too. That's a prime number. That's okay. Anything that has more than one factor, so these ones right here, these are called composite numbers. And what that means is that it is a composite number because it has more than 2 factors. Okay, it's more than just 1 in itself. So if you look here, it's 1, 4, and 2. 1, 6, 2, and 3. So they're called composite numbers. Okay, that's Mr. Wicklum's math lesson for today. This is Mr. Wicklum signing off.